Now that we've calculated all of our part positions for our cutter, we can go ahead and we can add the G&M code to drive the cutter from the start to the end position as shown here. First, I want to talk about why I have this arc here and here. It's best to always arc onto the cut and arc off for two reasons. If I feed straight in, that doesn't load the cutter up very nicely as it comes into the cut. Arcing in will load the cutter up gradually and greatly reduce the chances of picking up chatter. Feeding straight in also can leave a witness mark on the side of the part that no customer likes. When we arc in, that tends to never leave a witness mark unless we are in single block and hesitate the cutter too long here. So arcing in and arcing off the cut is the best way to load up your cutter. Now the cut path we've drawn here is actually the finish cut. It's not the rough cut. So that was the fourth tool we were going to program. So I'll go back to NC Plot, and what I've done is I've cut the first three tools out and I've pasted them down here at the bottom of my program right after the M30, so the simulator won't try and run them, and we'll bring them back as we code them. So I'll go back up to the top. The other thing I need to do, we're using a carbide end mill. Remember, a slot drill is a 2-flute end mill that cuts on center. So I've gone into the machinery handbook and looked up the recommended speeds and feeds and posted them here. So for end milling with uncoated carbide, the machinery handbook recommends a cutting speed of between 620 and 2020 feet per minute and a feed per tooth of 15 thou per tooth for optimized cutting, and the average it tends to be 8 thou per tooth. So I'll scroll down a little bit, and using this information we can go ahead now and we can calculate our RPM. So I'll bring up the calculator. So I'm going to use a cutting speed of 2000 because I am using coated carbide. So I'm going to enter 2000 times 4, then I'll divide by the tool diameter of 3/8, and I get a very fast RPM, 21,333. And yes, when we cut a lot of aluminum, we tend to buy high-speed spindle machines. I don't have a high-speed spindle machine. My maximum RPM is 8,000. So what does that mean? Well, I might be going slower than ideal or optimized conditions, and my tool won't last as long as possible. But I have to work with what I have. So I'm just going to clear this. I'm going to redo the calculation. What if I were using the 620? Then I'll multiply by 4 and divide by tool diameter, and I get roughly 6,500. Well, that's within the range of my spindle. So I'm going to go ahead and I'm going to run this tool at 7,500. My max speed is 8,000, and I don't like to run my spindle at its top. So I'll program 7,500. So next, let's bring our part drawing back up. So here's our start position, and we're going to program the center of the tool path. So I need to put its X and Y location at the start into here. So I'll go back and look that up because I don't recall what they were. I'll just move this over here. So my X cutter center at the start is 1.572. So I'll come over here and I'll backspace this. I'll enter 1.572. I'll bring that back up again. And my Y cutter center at the start is negative 1.8835. So I can program that here. So I've now calculated my RPM and programmed it. And I programmed the center of the cutter's start position in both the X and Y axis. And in the next video, we'll come down here and we'll code this tool to cut the part.